Hello, and today we're going to be talking about current and wind problems. Now, you are all masters or almost masters of substitution and elimination, and we need to show you guys some applications of why we kind of do that, because it's always good to know why you're doing the maths. So, let's look at some. A canoe can travel a 24-mile river downstream in 4 hours. And for those of you not fluent in the river terminology, um, here is a beautiful river. I know, just a Picasso-like work here, or maybe a Bob Ross. And if you are, let's have the blue represent the current. So blue is going to be the current, and you are going to be red. If you are traveling downstream, that means that you are traveling with the current. So let's have downstream means with the current. Downstream is equal to with the current. So your speed is going to be faster if you are traveling downstream because you're going with the current. If you are going the other way, oh, there we go. If you're trying to going upstream, upstream means that you are fighting this current. So upstream is equal to against the current. That's an N. Against the current. And this is important because when we're setting up these equations, we kind of need to know what the question is actually talking about in general. So the question asks, what is the current speed and what is your speed? Current meaning what's the speed of the water of the river. So whenever I'm trying to do these problems, I really need to define what my variables are. So I'm going to have x is equal to my speed, and y is equal to the current speed. Now, if I'm going to be traveling downstream, that means that I'm going to be doing that in a certain amount of time, and that time is 4 miles per hour. So 24 divided by 4 is equal to 6 miles per hour. So traveling with the river, or x plus y, that is equal to 6 miles per hour. And the reason that I'm doing that is because x and y are both speeds, and a speed plus a speed has to be equal to a speed. If you did x plus y is equal to 24, you're saying speed and another speed is equal to distance, and those units don't match up. So we need to make sure we do that correctly. Now, you're going the same distance, but if you're going upstream, it takes you 6 hours, so an additional 2 hours. So I'll have 24 divided by 6 is equal to 4. So x minus y, your speed minus the current because you're going upstream, is equal to 4. Now, here I could solve it in any kind of way I want to, but the easiest way is going to be elimination, and I can do that by adding these two equations up, and I get 2x is equal to 10. And the reason we want to do elimination here is because our y's have those coefficients that are additive inverses, right? We have those opposite coefficients. One has a coefficient of 1, the other y has a coefficient of -1. So going back, solving this gives me x equals 5. And I'm going to actually write that as a sentence. So I'm going to have my speed or your speed. Let's say your speed. Your speed is 5. And again, the right units, miles per hour. From here, I need to figure out what the current speed is. So I'm going to have 5 plus y is equal to 6. Therefore, y is equal to 1 mile per hour. So the current speed, or speed of the current, is 1 mile per hour. And that makes sense, right? Because if you can check that answer by putting 5 and 1 back into this bottom equation and say 5 minus 1 is equal to 4. And it is. So we know that that is the correct answer. So your speed is 5 miles per hour. The current speed is 1 mile per hour. Now, this doesn't also just apply to water, but it also applies to wind. So say you're on an airplane and you're traveling from Charlotte to LA and you're going to be flying into the wind. If you're flying into the wind, it's the same kind of thing as traveling upstream. You're fighting the current. So let's have x equal the airplane speed and y will equal the wind speed. And if I'm going to be traveling into the wind, that's going to be an x minus y. My speed minus the wind speed is going to be equal to 2,400 divided by 6, which is 400 miles per hour. If I'm flying with the wind, it's going to take me 5 hours, so I'm shaving off a whole hour there. That means that would be x plus y is equal to 2,400 divided by 5, which is equal to 480 miles per hour. And again, here I'm going to be doing elimination. I add these up and I get 2x is equal to 800, and, oh, that's an 8. 8, that looks a little stupido right there. So 2x is equal to 880, which means x is equal to 440. And again, the reason I say what my variables are is because when I come back to writing out the final answer, I know that 440 is equal to the airplane speed. So the airplane's speed is 440 miles per hour. Plugging that in, I'm going to be solving that for y. 440 plus y is equal to 480. Therefore, y is equal to 40 miles per hour. So 40 miles per hour is the wind speed. And again, this problem is very, very similar to the current one. The only difference is that I'm talking about air instead of water here. So you try. Pause the video here and solve it. When you're done, come back. So you solved it and you have found out that your speed was 3.5 miles per hour and the current speed is 1.5 miles per hour. In terms of final answer here, I'd like you to write your speed is, not your speed equals. But if you get this right, move on. If not, stick around. I'll explain it. So you're rowing up speed, and this one it actually tells you, we don't know anything about the distance, but we're already told what the speed is. So upstream, again, we know that means x minus y. If x is your speed and y is the river speed, or the current. I don't know why I say river speed. The current speed. Current speed. So that is equal to 2 miles per hour. Traveling the same distance downstream, so you're going to be adding your speed and the current speed, that's equal to 5 miles per hour. Doing elimination here gives us that 2x equals 7, therefore x equals 3.5. Plugging that back into this equation right here says 3.5 plus y is equal to 5, therefore y has to be equal to 1.5. And because I had y equal the current speed, that means that the current speed is 1.5, and x is my own personal speed in this canoe or whatever boat. We're rowing, so I'm going to go with canoe. Could be a yacht, you're rowing it. Those, you need very big oars there, but you never know. Maybe that's why you're going so slow. But your speed is 3.5 miles per hour. Okay, next problem. Pause the video here, try it out, come back to the answer. Okay, if you have completed this problem, you have found out that the plane speed was 375 miles per hour and the wind speed was 75 miles per hour. Make sure that you have taken detailed notes on this, as I will come and check them tomorrow, or your teacher. Not necessarily that'd be weird if I came into your class. But if you got it right, stop the video and have a great evening. If not, stick around, I'll explain it, and hopefully still have a great evening. So from Charlotte to Cleveland, it is 540 miles. With the wind, it takes 1.2 hours. So what I'm going to do here is I'm going to say that x is equal to the plane speed and y is equal to the wind speed. Now, that means that with the wind, x plus y, because I'm going with the wind, I'm not fighting it, I have to do 540 divided by 1.2, because that's how long it took me. And that will give me that total speed there would be equal to 450 miles per hour. If I were going to be traveling against the wind, that takes me 1.8 hours. So I'm going to do 540 divided by 1.8, and that will equal 300 miles per hour. So there's a whole difference of 150 miles per hour here. And if I were to do the elimination, which I think we're pretty good with this part by now, I would have 2x equals 750. Therefore, x equals 375. So that means that the plane speed, because x is my plane speed, would be 750 miles per hour. Plugging that back in, 375 plus y equals 450, which means that y equals 75. Just subtract 375 from both sides. All right, thank you for watching, and have a good day / evening / morning if you're one of those people. Bye-bye now.